Okay, I think we've started. So, as you guys are beginning to join, please put your questions on the Q&A bar, and I will start addressing them as soon as I can. Michael Jenkins, I think you have joined this instead of viewing it. I think you...
Yeah.
All right. All right, so the first question is from Ephraim. He wants to know what kind of questions you're allowed to ask, because he wants to ask basic questions because he doesn't feel like he is, I guess, knowledgeable on this so far. Ephraim, please feel free to ask whatever questions. I'd like them to be topical, at least on the topic of the unit test. So as long as they're on topic, that's fine. I figure you guys will probably be asking questions about the practice test. You'll probably be asking questions about 5A or 5S. At least that's kind of what I'm hoping you'll go towards. I have those documents. Just want to double check. All right, worksheet solutions, worksheet number 5, Joanne. Okay, you stumped me. I don't know which worksheet that is. Is it the practice test? Let me take a look. All right, so I'm going to select that question. Joanne asked for solutions number 5, solutions worksheet. I don't know if that means that that's the practice test because it says solutions on it. And if it's the multiple choice or the free response, I am, as I said before, a little bit stumped. And Efren says solutions worksheet back number 1. Wow, now I'm in real trouble. Don't know what you guys are talking about. Let's see if I can figure this out. I don't have a worksheet titled solutions. I'm going to assume you mean the practice test. So that's what I'm going to do. And then if it's not that, if you guys can ask with a bit more clarity, probably be helpful. All right. All right, so practice test, solutions, number 5. How many milliliters of 11.6 molar HCl must be diluted to obtain 1 liter of 3 molar HCl? So this question is about a dilution. So M1V1 equals M2V2. So I'm going to go ahead and share the bamboo tablet. Okay. And oops. Okay. Practice test, multiple choice number 5. And you have 11.6 molar, and that's your, so you have, I'm sorry. You know what, I don't like it that thick. It's much easier when the ink is narrower. Okay, M1V1 equals M2V2. And the question for number 5 is you want something to dilute something. So we have one, we have the M1, and we don't know the V1. We have the M2 and the V2. All right, so I would say let's put our red around V1. So V1 is equal to M2V2 over M1, which is equal to 3.0 molar and the volume is 1.0 liter. And all this is over 11.6 liters. And it says how many milliliters of 11.6 molar HCl must be diluted to obtain. Okay. And this is multiple choice, which means there are no calculators. So really what you're dealing with is 3 over 11.6, which, you know, you could make the argument that that is roughly 3 over 12, which is equal to 1 over 4. And so the question is, what would that be in liters? 1/4 would be 0.25, about 0.25 liters, which is about 250 milliliters. So we look for an answer that's kind of close to that. And C, which is about 260 milliliters. So I'm assuming, Joanne, that your question is about the fact that there is no calculator on this, and 3 over 11.6 would definitely seem like a frustrating number to try to come up with. So it's a lot of like finding numbers that are similar, kind of process of elimination. If you look at your options, 3.9 milliliters, 35 milliliters, 260 milliliters, and 1,000 milliliters, 260 is the only one that's even close to what you need. You know that it's not 1. You're not 3.9. Oh, excuse me. You know it's not 3.9. So you just kind of process of elimination, you get to it. So that is how you do that one. Oh, so as I go back to say I'm done with that one, I've got another, not practice. Fantastic. All right, let's see if I can figure this out then. Efrain said it's the last one, Schoology. I don't know if it's I don't know if you guys are talking about the same one, so I'll look up Schoology. See what I can come up with. The molarity dilution neutralization. Okay, this can't be right. All right, so what I'm going to do is I'm going to share where is it? Just going to share my whole screen for a second. Oh, that's not going to work very well. And so when I go to Schoology, the very last thing I see under Unit 3 Solutions, I go to the bottom and it says molarity dilution neutralization, which is not solutions. So I don't know what that is. Maybe you guys could give me a better name for what you want. I don't know if you guys can look here and see what the name is, the name on the, because I don't know another worksheet that's just named solutions. It's not the practice test. So if you guys can type that in and let me know, and then I'll go on to that one. Okay. Let's get off of this. That was annoying. All right. Oh, a frame. It is that one. That is the one. I'm just going to assume, unfortunately, because I can't understand the single words, I'm just going to assume that's what you mean. So you mean at the very bottom of this, molarity dilution neutralization worksheet. So let's just open that one up and take a look at it. All right, so I I guess if I was going to go back and I don't know if I'm sharing it. So if the one that you really mean, Joanne, is the number 5 on that sheet that I just did, let's take a look at it. A solution was prepared by mixing 100 milliliters of 0.2 molar HCl and 150 milliliters of 0.1 molar HNO3, nitric acid. Calculate the molarity of the final solution of H+. So if I do that, share my Bamboo tablet again. So from molarity and dilutions, number 5. That question is, let's see, it's again, it's, okay. We have 100, this is what I should remember, it's all about the moles. I cannot emphasize moles enough. Moles, 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 moles. Molarity equals moles over liters. So moles equals molarity times liters. Mole is equal to 0.1, or let's do it the same way. .200 molarity times 0.10000 liters gives me 0.020 blah 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 moles. And then mole is equal to 0.10 times 0.15000 equal to 0.015 moles, and 0.020 plus 0.015 equals 0.035 moles of H+. And I should have done this in a whole new paper, but that's okay. 0.035 moles of H+ divided by 100, or obviously 0.100 liters plus 0.0150 liters equals, and so basically it's, oops, not 0.0. I did that earlier today too. I keep messing up my zeros. 0.150 liters. So 0.035 divided by 0.1 plus 0.15, and I get for an answer 0.14 molarity of H+. And I can do all that because HCl and HNO3 are strong acids and they dissociate. So that would be my answer to number 5. All right, now we're going on to Ephraim's question, number 1, on the acid-base neutralization side. And number 1, a neutralization of phosphoric acid with sodium hydroxide. Right. Let's change colors. Green. Okay, so it's MAVA equals MBVB. Since, oops, I should probably say which one this is, just everybody's looking. Okay, so acid base, neutralization. Number 1, we have MAVA equals MBVB. And so we don't know MA. That's what we don't know. So MA is equal to MBVB over VA. So the molarity of the base is 0.532 molarity times 0.0208 liters, all divided by the volume of the acid, 0.0450 liters. So I plug that into my calculator, 0.532 times 0.0208 divided by 0.045, and I get the molarity of my acid being equal to 0.2459 molarity of H+. Now, if you'll remember, when I do this, MAVA equals MBVB. It's all about the moles of the H+ being equal to the moles of the OH-. Okay? Now, phosphoric acid is H3PO4, so that's an issue because that means that it's not just one H+, that's 3 H+. So I take my 0.2459, and that's the molarity of the H+. I make a bridge, and for every 3 moles of H+, that's 1 mole of H3PO4. So you divide this by 3, and I get 0.081967. So if I round to 3 sig figs, my answer can only have 3 sigs. 820 molarity H3PO4. So that's what I get for my answer for number 1, the backside. So it's just a MAVA equals MBVB, but you have to remember that when there's more than one H or more than one OH, you might have to multiply or divide to get your final answer. Okay, so that answers that question. I'm willing to go back to any of that. No, I meant 1 on the other side. Okay. So now I'm doing 1 on both sides. To what volume should 5 grams of KCl be diluted in order to prepare 0.25 molar solution? Okay. So we have, this is on the molarity and dilution side. Number 1, 5.00 grams of KCl. Okay, all about the moles. Molarity equals moles over liter. Okay, well, we need moles first. So KCl, I look in my periodic table, make a bridge, and 1 mole of KCl on top. And when I add those two together, K is 39.10 plus Cl, which is 35.45, and I get 74.55. 74.55 grams of KCl, which means that I've got 5 divided by 74.55. And my number of moles, 0.06707 moles of KCl. And so I'm looking for liters to what volume. So liters is equal to moles divided by molarity, which is equal to 0.06707 moles of KCl divided by 0.25 molarity of KCl. And my volume divided by 0.25. With only 2 sig figs for an answer, 0.27 liters of KCl. Well, in that case, you might almost say that it's water was added, but that's the volume of KCl. So volume should, and I guess we should just label that water. That would probably be the smarter thing to do. Because it's not really, because we're not talking about concentration. This is just, so we're adding that much water to the grams of KCl, assuming that there's no increase in volume by the mass. And that's your answer. Right. I think I saw Arya had a question a while ago about, I'm going to jump down to one of his, multiple choice and free response. Let's do the multiple choice one first. Multiple choice number 3, practice test. So, there we go. Let's share the practice test. All right. Multiple choice number 3 is has an equation. When the equation for the half reaction above is balanced, what is the ratio of the coefficients of OH minus to CrO2 minus? That one looks like a pain. Excuse me. So let's do it. That's what we do here. We do the fun ones. All right. So what we have, let's see if I can do this as a matter of fact. Let's change to red. So this is the practice test, multiple choice number 3. So we have CrO2 minus plus OH. OH minus CrO4 2 minus plus, oh, I'm having such a hard time remembering those lines. Plus H2O plus electron. So this is the half reaction to balance. By the way, my computer keeps beeping at me. I am under the suspicion someone is trying to get a hold of me. Oh, Serena, for some reason my questions are not posting. I was hoping that you could go over acid-base neutralization number 4 and worksheet 5 number 3. Okay. So I'll come back to those. So Serena, I got them. All right, I know them now, so I'll come back to them. I'll do 2 from Arya, and then I'll come back to it. Okay. Show. We're doing the balancing equation. All right. Now, we know that whatever it is that we come up with, the ratio is like, we have a 1 in front of the CrO2 minus, or it's like a 1, 1, I mean, sorry, it's like a 1 to whatever, or 1 to 2, or a 2 to 4, or something along those lines to balance that equation, just looking at the answers. So, obviously this one's going to take a little while. I would wait until the very end to do this, but because, I mean, at some point you can just kind of guess, estimate. So let's see. So I know that there's that my equation is cut in half right here so that I know what I have to balance. The chromiums are balanced already, which is easy enough. There are 2 oxygens here. There are 4 there plus a 5th one here. Oh, there's 3. I'm sorry, there's 3 plus the... Okay, now we've got 2 hydrogens right here. If I just make this really simple to begin with, I guess I would put it 2 right here. And that is... So I've got 2 hydrogens and 2 hydrogens. So I have 2 oxygens, 2 oxygens, 4 oxygens, 5. So that won't work very well. I need probably... Let's make this an even number on the bottom, because that's usually what happens. What works best is if we double things. And we're going to have the number in front of the OH minus is going to have to be an even number, because this is an H2 and there are no other H's on the right-hand side. So that means that whatever number we pick for the OH minus is going to have to be even because of the H2 right here. So I'm going to make this a double here. So that means that I'm going to change this to a 4. So now I have 4 hydrogens and 4 hydrogens. Now I have 4 plus 2 is 6 oxygens, and I have 4 plus 2 is 6 oxygens, and I have a chromium and chromium. Actually, that was pretty straightforward. 4 OH minus to 1 CrO2 minus. And if we look back, that was the answer. It was letter D. So that worked out okay. I guess maybe sometimes they're easier, sometimes they're longer, but sometimes they're easier. And just take it slow, take it one step at a time. Don't try to pick it all apart in one fell swoop. All right, so I'm going to do free response number 3 on the practice test right now, and then I'll go back and do the ones that Serena had asked for. All right. Oh. Excuse me, I opened up the screen right in the middle of my yawn. I apologize. All right. Response number 3. Okay. So a 500 milliliter sample of aqueous calcium hydroxide requires 34.66 milliliters of 0.0980 molar nitric acid for neutralization. Calculate the concentration of the original solution of calcium hydroxide. So it's an MAVA equals MBBB, which is moles of H plus equals moles of OH minus. And we're looking for calcium hydroxide, which is the base. So when you solve this initially by plugging in all of your acid-base things, you find the molarity of the base, molarity of the OH minus is 0.0678. You can see it here. So you just solve the OH minus. Now, calcium hydroxide, calcium is an alkaline earth metal, which means it's a +2. Hydroxide, as you remember from your polyatomic ions, is an OH minus. So it's a 2-to-1 ratio. So when you do that, it takes 2 moles of OH minus for every 1 mole of calcium hydroxide. So you have to take that number and divide it by 2 in the bridge, and that gives you the 0.0339 molar calcium hydroxide right here. This is just sort of an abbreviated answer I use for my key, but if you had made the bridge right here, you would have this is your given, and then you would have had on the underneath 2 moles of OH minus to 1 mole of calcium hydroxide. So it's important to remember that, because of course that comes up on the test. Why don't I just show that on a... I'm just going to show that real quick on the Bamboo's paper, so you guys can see it. That if you have 0.0678 molar OH minus, your bridge would be for every 2 moles of OH minus, you get 1 mole of calcium hydroxide. So that's how you do that. So that the molarity, or what I should do is the concentration of the CaOH2 is equal to 0.0339 molar CaOH2. Okay. Excellent. All right. So now we're going to move on to the question that Serena had. So she had two questions actually. The neutralization, acid-base neutralization number 4, and worksheet 5A number 3. So let's see. That would mean, let me pull that up in the share, acid-base neutralization worksheet first. So acid-base neutralization number 4. And so we'll do that one really quick. All right. And this one, it's a neutralization, which means we're using MAVA equals MBVB. So I'll change the ink color on this so I know you're making a change here. Just make sure. Good. Acid-base neutralization. Number 4. And so what you will need to do is, correct for molar mass. Actually, you don't need to do the MAV. Well, you can do it because you're missing some data. So what you would actually do is, remember, it's all about the moles. It's a neutralization. So if we have molarity equals moles over liters, and we're looking for moles, moles equals molarity times liters. So moles are equal to 0.800 molarity, and the volume is 0.0100 liters. That means our moles of NaOH are equal to, I think it's 0.38, 0.8 times 0.0. Help if I turn on my calculator, times 0.00, nope, 0.01. Yes, 0.008, okay. 0.008 moles of NaOH, and it's a 1:2 ratio, meaning that if I have, I'll make a little bit, 0.008 moles NaOH, that means for every one, oh no, I'm sorry, I did that wrong. For every 2 moles of NaOH, we have 1 mole of, we'll call it H2A. That's an acid. Generally speaking, like a generic acid is just HA, except for that it's a 1:2 ratio, which means this has got 2 H's. So that means that it's equal to 0.004 mole of our unknown acid. And we'll call it diprotic. There's 2 H's. And so now that we have the number of moles, it's looking for the molar mass. And if you remember, molar mass is equal to grams per mole, which is equal to 0.664 grams divided by 0.004 moles. So together, 0.664 divided by 0.004 equals 166 grams per mole for your unknown. All about the moles. Keep coming back to the moles. All right, let's move on to Serena's next question, which was worksheet 5A number 3. So let me pull up 5A. Number 3. All right. Excuse me. All right. So everybody can see what we're looking at. This is the one where you have the hydrated barium chloride. And you dissolve it in water to make 250 milliliters. And you take 10 milliliters of that solution, and you're going to react it with silver nitrate, and you find out exactly how much silver nitrate it takes, and then you can work backwards from that to give the actual ratio. So let's see. Let's show that bamboo tablet. It might take a couple pages in the bamboo tablet. This is sort of a long one. All right. So we'll do this in the standard blue. Worksheet 5A, number 3. All right. All about the moles. So we have 0. Actually, let's start with writing down the equation, or because I skipped that part. Molarity equals moles over liters, so moles equals molarity times liters. So moles equal to 2.530 times 10 to the negative 2 molarity times the volume, which is 0.04692 liters. So that makes that equal to 0.001187076. Excessive, but I don't have to round to the very end. Moles of AgNO3 minus. And we can say that once we have the moles of silver nitrate, we want to know the moles of chloride. And if you look at your paper, you see that Cl minus plus Ag plus yields AgCl. So it's going to be a 1-to-1 ratio, but basically, I mean, just so that you know that's what it's supposed to be, 0.00118. Why don't we just do this? 1 moles of AgNO3 for every 1 mole of AgNO3, we get 1 mole of Ag plus. For every 1 mole of Ag plus, now we're talking about the balanced equation up here, we get 1 mole of chloride, which means that we have 0.0011871 moles of chloride. Okay, now that was how much we have in 0.01 liters. We want to know how much there is then, X amount, if it's 0.250 liters. Okay, and when we solve this equation, we come out with our moles of chloride. In the original, 250 was 0.029675. It's moles of chloride. Okay. Now, once we have that, we want to go back and see how many moles of barium chloride that was. So 0.029675 moles of chloride. Draw a bridge here. For every 2 moles of chlorine, we have 1 mole of barium chloride, BaCl2. So that means that that is equal to 0.014838 moles of BaCl2. which has a molar mass which is equal to 208.23 grams per mole. Okay. Now, we take that and we multiply that to find the grams of barium chloride. So that's 0.01448838 moles of barium chloride. Put a little bridge here. And for every 1 mole of barium chloride, we have 208.23 grams of barium chloride. And that will end up being equal to 3.0897 grams of barium chloride. So that is good, but if you look at your paper, you'll see that we had 3.364 grams of the total sample. So it's minus the 3.0897 grams of the barium chloride, which then makes it equal to 0.2743 grams of water. Now we're going to take that and we're going to convert it to moles. So 0.2743 grams of water. Oof, horrible line. Still horrible, whatever. Don't have time. So we have 18.02 grams of H2O on the bottom, 1 mole of H2O on the top, which means we have 0.01522 moles of H2O. Great. Now we can do a mole ratio. Moles of water over moles of barium chloride. This should feel familiar. This is just like doing the empirical and molecular formula and when you do the combustion analysis. So the moles of water, 0.01522 moles of H2O over 0.0143838 moles of barium chloride. And that's basically 1-to-1. It's like, I can't even remember, 1.02 or something like that over 1, which is essentially 1. So it's a 1-to-1 ratio, which means that it is BaCl2.1 H2O. And that is the answer. 1 is the answer. Okay. Long but fun. So much fun. All right. So that answers that one. Now we will go on to free response number 4A on the practice test. And that's the one that Aria wants. Free response number 4A on the practice. So I'm going to share that one. Where's my practice test? There it is. Share. Oh, this wasn't it. Wait, where am I? Here we go. Free response number 4A. Oh, okay. Oh, yeah. So it doesn't show the whole thing of how to solve it. Meaning like how you balance it out. So I'll walk you through the balancing part. Calcium carbonate and sodium sulfate, and precipitated out the calcium to calcium oxalate, which is then dissolved in sulfuric acid, and the resulting oxalic acid is titrated with potassium permanganate. Okay, so let's go ahead and do that on our bamboo tablet. Okay, let's do a new pad for this. Okay. And a new color. I'm going to choose pink because potassium permanganate is kind of a purple color. MnO4 minus plus C2O4 2 minus O plus H plus yields. Oh, I forgot. I should label what question I'm on. Sorry. Pre-response number 4A. Okay, let's try this again. MnO4 minus plus C2O4 2 minus plus H plus yields Mn2 plus CO2 plus H2O. All right. So now the first thing whenever you balance or whenever you want to balance is you have to separate out all of your ionic and leave your covalent. And as it turns out, you look at that, it already is, which is very nice. Second step is assigning oxidation numbers. So we start here. Oxygen is pretty much always gets a -2. So I'm going to change color for this. So that means oxygen is -2 right here. There are 4 of them, which makes this -8. And together they have to equal -1 because that's a polyatomic ion, which means this has to be +7, and there's only 1, so that's +7 for the manganese. Oxalate, again, oxygen is a -2. There are 4 of them, it's -8. It has to be equal to -2, which means this has to be +6, and there are 2 of them, so each one is +3. Hydrogen is just a +1. Manganese, just a +2, because it's manganese 2 plus. CO2, the oxygen, is pretty much always -2. There are 2 of them, so that's -4. It's 0 because it's a covalent. So the carbon has to be +4, so you put +4 there on the carbon. And H2O, it's getting to be pretty easy, -2 and +1. So the oxygen doesn't change at all. The manganese definitely changes, the carbon definitely changes. So looking at this, if the manganese goes from +7 to +2, its number was reduced. It gained electrons to make it less positive. And the carbon went from a +3 to a +4, so it was oxidized. It lost an electron, lost a negative, which made it more positive. So then I have my half reactions. I like to do oxidation first, because that's the way I am. So I have C2O4 2 minus going to CO2. And our carbons, so you balance all elements except for oxygen and hydrogen. So we balance the carbons first. 2 carbons on the left, so we put 2 carbons on the right. And so now we have the same number of carbons, and as it turns out, we have the same number of oxygens, 2 and 2. The charge is at -2 right there. So we have to add 2 electrons to the right-hand side to balance the charge. Now, for our reduction, I can tell you this one's going to be fun already, is an MnO4 minus going to an Mn2 plus. So balance the elements that are not oxygen or hydrogen, and that's manganese, and it's the same number. They have different charge, but same number. Then you balance the oxygens by adding waters. Well, we're going to have to add 4 waters to the right side so that we can get 4 oxygens to match these 4 oxygens. Then we have to add hydrogens. There are 8 hydrogens right here, which means we're going to have to add 8 H pluses on the left. And then we're going to have to balance the charge. That's 8 plus and 1 minus makes 7. This is a 7 plus on the left-hand side. This one is 1, 2 plus, so that's 2 plus on the right-hand side. So we need 5 electrons on the left. So they can balance out. And we've got 5 and 2, which means we're going to have to multiply these each times the same number. So 5 times, I'm sorry, not the same number, that we have to get the same number from the multiplication. This is 2 times. And so this is 5, and that's 10, that's 10. This is 10, that's 16, 2, 2, and 8. All right, so we add all of that together. We end up with, so it's top 5 C2O4 2 minus plus, now the oxygens, I'm sorry, the electrons canceled out on both of them. So that leaves us with the, we've done these right here, so we're coming with the 16 H pluses plus the 2 MnO4 minus yields 2. And we've got 10 CO2s plus 2 Mn2 pluses plus 8 H2Os. And that should be our answer. Look back at the key, and sure enough, there it is. So you got to make sure you practice going through all those steps. If you're having problems, go on sciencegeek.net, and I know he has some problems there that he can do. I'm sorry, on his practice. He's got some practice ones that are pretty good that I would strongly encourage you to check out. All right. So an Ephraim would like to see, okay, so I'm sorry, let me back up. That means that one's done. And so Ephraim would like to see 4B on the practice test. So I'll be there in just one moment. Okay. 4B on the practice test. So I'll open 4. Oh, so it's the same question. It's just that now we're just adding it up. All right. Again, I just want to emphasize it's all about the moles. All about the moles. So we did the titration, and titrations are all about moles. Let's try to match up the moles of the titrant with the moles of the analyte. The titrant is the one that you are dropping out of your burette. The analyte is the one that's in the Erlenmeyer flask. Okay, so let's go ahead and do it. Well, actually, I can just show you here. This is pretty easy. You had a certain number of milliliters. You know what? No, I'm going to go ahead and draw it because I think this is not looking okay right here. I'm going to just go ahead and do it on my bamboo. Keep wanting to call it bamboo stick. Bamboo sheet. Bamboo app. Okay. So let's go to the next page. Go back to the blue color. And we want to know the moles of the oxalate. So that's our analyte. So first we start with moles of the permanganate. And this is practice test 4B. Molarity equals moles over liters, so the number of moles equals molarity times liters. So mole is equal to molarity, 0.1092 molar times 0.03562 liters. So our moles are equal to 0.1092 times 0.03562, and I get 0.0038897, too much, but that's okay, moles of, and this is the MnO4 minus. And we want to know the moles of, it's just a mole ratio. Oh, that's pretty easy. This is just like the redox titration, almost exactly. 0.0038897 moles of MnO4 minus. And if we look back one page, because we're doing, so your mole ratio is your moles of MnO4 minus to moles of H2C2O4. So if we go back to our balanced equation back here, we see that it is 2 moles of MnO4 minus to 5 moles of the C2O4 2 minus, or 5 moles of the H2C2O4. So 2 to 5. So that means, oops, I'm gonna write 2 here and 5 here. I did that right? Yes. Okay. And when I multiply times 5 and divide by 2, I end up with 0.00, and with sig figs there are 4 sig figs. 9.724 moles. Oops. Moles of H2C2O4. All right, and that is the answer. So that's good. We'll be on the practice test. Are all titrations just redox reactions? No. Redox reactions have to have a change in oxidation number. And I would say that if you have an acid-base neutralization, I don't believe I don't believe that's a redox reaction. Yeah, I'm pretty sure it's not. Acid-base titrations are not redox reactions. There's similarities in the fact that sometimes you're doing redox reactions as titrations, but not all titrations are redox reactions. Okay. It's 8:59, and we've answered a few questions. Some of the questions were longer. I totally get that. You are more than welcome to come in and see me or email me or whatever you want to do. Efrain has another question. Efrain wants to know, why did you take out the H from the H2C2O4? So what I could do, since I'm in this same, I'm still in my thing here. We took the H2 out because it wasn't a part of the, like it's a spectator ion. We could have left it in if you have an overall balanced reaction. That's the problem with redox reactions. It's a net ionic equation. So you had to take the H out. So if you recognize that the MnO4 minus it gets titrated with a C2O4 and not the H minus, or the H pluses, sorry. That's why you take it out. And I have to go back here. That's what you're asking is, why are they, you'd have to go back to why did the H pluses get taken out of here? And that's because they're spectator ions and their oxidation number does not change. So it's acidified, which is why you have this, right here, this 16 H pluses. So you have an excess amount, right? If you took 2 out of those for every 5, you'd have 10 that you would take out and add to the oxalic acid, but you'd have extra acidic environment because you want it to produce the Mn2+. If it was a basic environment, it turns out to be MnO2, which is not as important for you. You don't need to know that, but it's important that it's an acidified environment, that there's excess H+, which is basically what that is telling you. But you don't have the H+ in there because of the redox reaction you already performed. That's why it's not there. That's why you don't have to include it. You have to include it in your final answer, and this is, but it's not a part of the reaction. So hopefully that makes sense to you. All right, so Joanne says thank you. Thank you, Joanne. Thank you for being appreciative. It's 9 o'clock, so I was going to stop unless there was something really pressing that you guys need to take care of. I don't want to cut you guys off. Those were some long questions, so if there was something you really wanted to have answered and there was an opportunity to do it, now is a good time to put it in there. I will take care of any questions you guys have because I want this to be useful for you, productive for you. But if there are no questions that show up, then this will be it. Please come in and see me. Don't forget to make a mole for mole day. Don't forget to bring in food. I guess that's not until Friday though, so it's it's more important that you take care of the lab notebook. There's a good one. Make sure that lab notebook is completed so that can get graded. And you want to get good grades on that. That's our first big lab grade of the semester. So anywho, I hope that that's good. I don't see any questions, so I'm assuming everyone's okay. So again, thank you very much for coming, and hopefully this gets viewed some more over the next 48 hours. People find use out of it. I guess that's it. Thanks a lot, and good night, and get a good night rest too for the next 2 nights. Important. Sleep is good. All right. Bye.